A potentiometer having a wire of 4 meter length is connected to the terminals of a battery with a steady voltage. In the secondary circuit, the Laclanche cell has a null point at 1 meter. If the length of the potentiometer wire is increased by 1 meter, then the position of the new null point will be. We have a potentiometer, and in the question it is given that the length of this potentiometer wire is 4 meter and the ends of this wire are connected with the two terminals of a cell. The upper part of this potentiometer is called as primary circuit. Now due to this cell, if I say potential of this point as VA and potential of this point as VB, so as you can see, if you go from point A to B, there is a drop of potential. So let us define one quantity called potential gradient as potential drop per unit length. That potential gradient, let us write it as K is equal to, here the potential is VA and at this point the potential is VB. So the drop of potential can be written as VA minus VB divided by the total length of this wire. It was given in the question as 4 meter. Now in the secondary circuit, there is a Laclanche cell connected, and in the question it is given that for this Laclanche cell, the balancing length is 1 meter. It means if you go from point A along this wire up to point J, then the length of this wire is 1 meter and there is no current passing through this galvanometer. Since there is no current passing through this galvanometer, and if I say potential here is 0, then potential of this point J will be 0. And immediately after this cell, the potential will be E1. Then up to point A, the potential remains E1. Then if we use potential gradient knowledge again, then we can write potential gradient is equal to, here the potential is E1. Then you are going from this point up to point J, the potential here is 0. So the potential drop is E1 minus 0 divided by the length of this wire. It is given in the question as 1 meter. So if you solve these two equations, you will get E1 is equal to this expression. Now in the second part of the question, it is given that if the length of this potentiometer wire is increased by 1 meter, then what is the new balancing point? So let us assume that new balancing point is somewhere over here. Let us mark this point as J prime. Again, by using the same concept, we can say the potential here is VA and potential here is VB. So there will be a potential gradient. So let us define that potential gradient as K dash is equal to drop of potential, that is VA minus VB divided by the total length of the wire. Now it has become 5 meter. Then from the secondary side, if you see, potential here it is 0, here it is E1. So up to point A, the potential remains E1. And then up to point this J dash, the potential is 0. So you can define potential gradient as E1 minus 0 divided by the length of the wire from A to J dash. Let us call that length as L. Now if you simplify these two equations, you will get E1 over L is equal to VA minus VB divided by 5. Now if you solve this equation and that equation simultaneously, you will get L value as 5 by 4 meter. It means the new balancing length is 5 by 4 meter.